Thank you. Good afternoon. So glad to see human beings in a room. It's so exciting. Okay. So then, I want to talk to you about an acronym, what I made up. But first I feel a bit of a backstory. So about 5 years ago now, which sounds like an incredibly long time, I was at a conference called NDC. So we're at YOW. YOW is an amazing conference. The GOTO group of conferences is great. NDC, similar sort of thing. Broad church. So YOW's background, YOW from Denmark, was originally Java and object-oriented, hence JAOO YOW. And a kind of counter to that was the .NET developer conference in Oslo, which was NDC. So they kind of grew up together. NDC, like YOW, like GoTo, big conference, generally sells out, right? So one of the folks there, Dylan Beatty, who's actually at this conference, he had this brilliant idea of having a mini conference in a pub afterwards for people who couldn't get into the main conference. So it's free, right? There's like a raffle thing. So you apply, the only criteria is that you didn't go to the conference. And then he grabbed a bunch of speakers from the conference. He's like, Bodo, fantastic, Liz, right, come in. You're going to do a 5-minute talk. It's like a Pacha Kuchak type talk. So you've got 20 slides, 15 seconds each, auto advance, right? And the entire rules are make people laugh, okay? And what happens at PubConf stays at PubConf, right? Nothing gets recorded. So he invited me and he said, do you want to give this talk? And I said, sure. And I was being quite angry, not angry, but a bit ranty about some of the clean code, particularly craftsmanship movement. Now, I'm a massive fan of craftsmanship as a thing. I find the craftsmanship movement a bit kind of young, angry blokey, is all I'm going to say. Anyway, so Dylan asked me to do this PubConf thing, and I'm like, I'm going to talk about solid, because this talk writes itself, right? So I called it Why Every Element of Solid is Wrong. So like one slide to introduce the thing, the letter, one slide to say why I disagree with it, and one slide to say what I do instead. 5 times, that's 15 slides, top and tail it, boom, right? So I did this. But what I found was, as I was writing the talk, every time, like my response to what I would do instead of single responsibility, open, close, whatever, was just write simple code, right? So try and write code that's really obvious, really kind of self-contained, blah. And then suddenly a lot of these things just fall away. And then I thought, is this just vestigial? Anyway, so I did this talk and it was fun and people drank beer. And then I made this crazy mistake of putting the slides online, right? So I put them up on Speaker Deck. And all hell broke loose, and all the bros came for me with pitchforks. Oh man, no, it was fun. Someone wrote a ranty blog post called Why Every Element of Dan North is Wrong. So it's my only ever hate blog post. I'm very proud of this. I feel like achievement unlocked. I pissed someone off enough on the internet that they had to tell me how wrong I was. Anyway, so that was it, right? And it kind of rumbled along a bit. And then beginning of last year, so beginning of 21, Extreme Tuesday Club, the longest running Agile meetup in the world, I believe, started in the late 90s in London, in various pubs, went online during the pandemic, is now back in face-to-face. They were having an evening of Solid. And one of the organizers, lovely Phil Nash, he said, hey, Daniel, you did this thing about Solid a while back. Do you want to come along and kind of take part? So I said, yes. And then he said this, he said, you don't like Solid, do you? I said, no. I said, I think it's just bad advice. It used to be good advice, it's now bad advice. I can defend that statement. And he said, right, what would you do instead? I was like, oh, you rascal. What would I do instead? And so that then leaves a question open, like, okay, if I don't agree with these principles, are there other principles that I do agree with? Are there any principles that are universally true about good software? Right, and Dave Farley's opening keynote this morning, he was saying these are things that he does, things that he cares about in good code. And there's a bunch of things in there that, yeah, I agree with, but there's some things in there, and this is another conversation I need to have somewhere else, is everything's a trade-off, right? So where we're doing these things, what are we trading off? What's the dark side of some of these? You know, if we over-index on all these things, does it always lead to a good place? Or does it lead to somewhere kind of dogmatic and overly zealous and stuff? So I took this challenge. I was like, okay, I'm going to see if I can come up with something. And I decided it had to be an acronym. I decided it had to have 5 letters, yeah. And I was like, well, what's the opposite of solid, right? What's the least blokey, macho thing? And it was February, and I was like, Cupid, right? We're going to have arrows and hearts and stuff, right? And ponies. And so now I had a backronym. I had the word, and I now had to make up things that were each of the letters, which is great fun because then you have loads of candidates. So I've got a whole series of blog posts that I still haven't written about what the shortlists were, right, for each of the 5 things. And then because I'm rubbish at following through on things. I love having ideas. I hate writing them down, it turns out. But someone around that time invited me to speak at a conference. And they said, oh, I heard about this thing you did at Extreme Tuesday Club. So now I suddenly had to put this thing together in a talk. And so this is several iterations on of that talk. So before I get into what Cupid is and what it means, I want to talk a bit about code. Who are we writing code for? Who are we writing code? Who is the audience of code? Right, that's a question, so you can say things. Developers, me, Corny specifically. So we're all writing code for Cornelius. There you go. That's who we're writing code for, which is fine. He's lovely. We should write code for him. Who else? Future colleagues. Yeah. There's a number of people who have, when I've encountered their work in my 30-year career, have really genuinely made me think differently about software. And Martin Fowler's one of them. I came across his refactoring book in early 2000s. He wrote it in 96 or something. And it's just, so the refactoring patterns themselves, there's a catalogue of really useful advice. The first couple of chapters where he just lays out what software is about is just beautiful reading. And he says this, right? He says, any fool can write code that a computer can understand. I was like, I know, I'm that fool. I do that. And he said, good programmers write code that humans can understand. I was enlightened. And I'm looking at this, I'm like, well, understand. I mean, understand's good, right? But can we do better than understand? And then again, far later than I should have, I came across something else, which was this gem from Dick Gabriel, who's one of the great granddaddies of modern programming. And he likes parentheses, so Bodil likes him. So that's how that works. And he wrote this brilliant series of articles in the 90s called Patterns of Software. And this one is Habitability and Piecemeal Growth. And honestly, look it up. It's a beautiful piece of writing, is what I'll say. It's a lovely piece of writing. And in the middle of it is this gem. It says, habitability is the characteristic of source code that enables, and he says various different types of people, to understand its construction and intentions and to change it comfortably and confidently. And I was like, comfortably and confidently sounds good, right? I'd like those things. Habitability makes a place livable like home. I was like, now we're cooking. Now we're cooking. Habitable. I like the sound of habitable. What about joyful? What about joyful? And of course, Jessica's opening keynote yesterday, where she's talking about bringing game design ideas in. Her middle name is literally Joy, right? So we've got that in the room. We have, anyway, think about what would joyful code be like? And so here's a thought, right? Some of you, particularly those of you who've been around the block a little, right? Think about a code base that you've been involved in that was joyful to use. When you crack it open, when you go in to look at it, you're just like, I get this. This makes sense, right? One of the very first code bases, my first job as a graduate, was a C programmer, which was hilarious because I didn't know anything about C. So they hired me as a graduate programmer and said, well, you're going to learn C, which I thought was a pretty good punt. And I did. And it was digital image processing. So digital image processing is basically taking lots and lots and lots of data of 4 points, which is cyan, magenta, yellow, and black colors, and putting them through huge transformations and coming out with another big set of data, which is 4 points, and that's called a color transformation. It's really big, complicated maths, and at that time in the early 90s, involved making computers do things that they weren't, you're kind of stretching stuff at that stage. Nowadays, you could do most of what we were doing on your phone, right? So there's that. But at the time, it was hard. And I remember I'm this like, dewy-eyed, bushy-tailed graduate, and there I am thinking to myself, okay, I've got to go in and fix a bug in this code. It's not my bug, but it's been assigned to me. Dan, can you go in and take a look at this code? It's not, there's some, when we put this image in, there's these weird blotches in there that shouldn't be there. So I'm like, okay then, and I'm like, I've got this look of terror on my face, is what's going on. I'm like, I'm going in, unfamiliar code, a language I've just about kind of got the hang of, and I've got to go and find this. Anyway, so I crack open this code in VI with C tags, and much to the Emacs people's dismay, and I just looked at the code and I was like, I know what's going on here. And then I navigated into kind of this path of code and figured out where things were. And I basically navigated straight to where the bug probably was. And the bug was a really obvious, like a less than or equal instead of a less than or something like that. Some really obvious logic bug. This is before test. We didn't do automated testing then. But so I had this bug, fixed the bug, or at least changed the code, rebuilt it, ran it, it all worked. And I was like, thank you, the person who wrote that code. Thank you, the person who decided to give things proper names, structure things well, make it easy to navigate, all of those things. And I remember that feeling of, I'm going to say joy. I hadn't evolved an aesthetic for code enough yet to appreciate it in a way of this joy. This was sheer cold relief, right? This was, because like you've got, when you're a shiny grad, you don't have imposter syndrome, you're an imposter. Right? So there I am, hoping I'm going to wing it. And then luckily, this person had left this code in a way that I could wing it. Can we describe what makes code joyful? Right? Is there a way to articulate it? And what kind of properties would joyful code have? And there's a kind of the broader question here is that are there a set of properties, right, that all code would have that would make it joyful? And I'm being very deliberate with my language here. I'm talking about properties rather than principles. Okay, and again, this is where I kind of diverge from a lot of the crafts people. I'm not going to say craftsmen; they're all blokes. And so, principles are rules, right? Principles are rules or guidelines, and they define what we call boundaries. Okay, you're inside or you're outside. Okay, and this is great because if you're a kind of code craftsman police type, that's violating the single responsibility principle. That's violating open close. Wow, God, I'll get written up for that. Here's a ticket. You either conform to this thing or you don't. And there's a chap called Paul Hebert who I discovered through someone else. He was a missiologist, and a missiologist is someone who studies missionaries, right? Christian missionaries, which I didn't know was a thing. It's a thing. And what he was doing is he was trying to figure out some missionaries are just more successful than others, right? They go into places and they have an impact. And when they go, people go, wow, that was amazing. And we're going to carry on doing that. And other places, they go in and they go, whew, glad they've gone. Right, back to what you're doing. And he discovered that the kind of the style difference, if you like, is that one of them talked about a centered principles and centered faith. And the other one was a boundary faith. So a boundary faith is words you use, clothes you wear, food you eat or don't eat, rituals you observe, right? And people who do all that are inside the tent, and people who don't do all that are outside the tent. And the classic, us and them thing that Linda Rising was talking about yesterday, if you were there, that it's a great way to other, yeah? And so when you do that, rather than caring about the thing in the middle, you just care about guarding the boundaries, yeah? And that's exhausting, right? And also you just tend to forget why after a while, and then it becomes really adversarial. Or you talk about a center, and that center will be a center based on values or beliefs or whatever it is. And so there's no edge, right? You're nearer to or further from the center, okay? But you're not, there's no outside or inside. Okay, and there's always a direction of travel. You can always be closer to the center or further from the center, but there's no exclusion. Yeah. So properties then are characteristics. So I looked up someone challenged me about this, and they said, in logic, a property is a binary thing. I'm like, I've got a maths degree. Let me tell you about predicate logic. You're describing a predicate. A property is something like redness, right? And you can have more or less redness. So it defines a center, yeah? And so you're closer to or further from the center. So what I've noticed, for me, code isn't good or bad. There's just certain aspects of it you're like, this is easier to work with than that code. Can I articulate why that might be? So this is very strange. It seems like my timer just seems to be doing really crazy things. Oh, I see what I've done. I've set my timer, instead of being 39 minutes, I've set my timer to 39 hours. I hope you're all very, very relaxed. We're going to be here a while. Right, there we go. Today I learned. I'm like, that's not going down very fast. Oh, okay, now it makes sense. So I'm going to get a bit meta. If I'm going to have properties, what properties should my properties have? And there's three things. The first thing is they need to be practical. Okay, if I'm going to describe what I think makes good code, makes joyful code, or code joyful to work with, they need to be easy to articulate, easy to assess, easy to adopt. There's no like all or nothing. We can say, I'm going to describe this thing and you want to get it. Right? If I can't describe it in a way that you can get it, that's on me. Right? If I'm describing it and you're not getting it, and, oh, you're stupid, you don't understand my thing. No, I'm a really bad communicator because you don't understand my thing. So it needs to be easy to articulate because it won't be me articulating it. Hopefully it'll be you articulating it to your buddies and them to their buddies and so on. Easy to assess, right? So when I talk about these properties, I'm going to look at my code and say, to what extent does my code have that property? And if I can't tell, then it's not particularly useful. And likewise, easy to adopt, right? So there's 5 of these things, CUPID. And so you're not going to try and do all of them at the same time because that's going to get really confusing. So there's going to be certain ones that you might decide to go after first for a certain piece of code. Next thing is it needs to be human. And let me explain what I mean. These are properties about code from the perspective of a human being. This is developer experience in the emotive sense of experience. There's a wonderful, wonderful UX researcher at Microsoft called Bill Buxton. And I saw him do a talk once, and he said something that you hear some things that are incredibly simple, and you go, poof. So he said, what is user experience? So I'm going to put you on the spot. What is user experience?
Apart from it's what the user feels when they're using their software.
Give that man a star. It's what the user feels. User experience is the experience the user has. Shock, right? It's not the design or the look or the feel or the consistency or the blah. It's the emotional response that someone has to using your product, right? So user experience might be frustration, might be resigned indifference, yeah? Satisfaction, right? So user experience might be like, I used that and it was fine. Gov.uk, the government's UK website that was rewritten by a bunch of jokers about 10 years ago. I love this story because 30 people in 8 months rewrote the whole of the government's front-facing website. It took less time and less money than the procurement document for the previous one. Wow, right? And it's never gone down, and it's served billions of impressions. It's all running on Django. It's all open source. But they have a design guidelines. And number one design guideline for gov.uk is no one wants to be here. Right? Isn't that brilliant? Right? I mean, like Facebook or whatever, it's how long can we keep them on the site? If someone comes to gov.uk, it's because they want to know what the VAT rate is, or when the next public holiday is or whatever. They just want to get done and get out, right? So if you can make it so they can get done and get out, you did a good job. No, rule 1, no one wants to be here. It's like, you get me. You get me. You understand what I'm trying to do here. So we want to look at code from a perspective of human beings who are reading it as well as writing it. Remember, code gets read many more times than it gets written. And the third thing we care about with properties of properties is that it's nuanced, right? So it's not just here's a simple black and white definition and blah. It's, if you're fresh out of school or career change or whatever, however you ended up in our fun, crazy world of typing things into computers, that there's something you can immediately grab and run with and find useful. But also, as you kind of go around it a bit more and you want to kind of chew on it a bit, there's depth to it, okay? So I want it to have some kind of immediate guidance and some kind of nuance. So then, without further ado, here's the reveal, right? CUPID, 5 things. Composable. I want code that's composable. I want code that plays well with other code. I want code that follows Unix philosophy of doing one thing well. Okay? I want code that's predictable. It does what I expect, and it keeps on doing what I expect. I want code that's idiomatic, so code that looks like all the other code. And I want code that's domain-based, right? So I want code that's domain-based, uses domain language and domain structure. And what I'm going to do now, it's okay, you can photograph this if you like, I'll put all these slides online. I'm going to unpack each of these. I'm going to spend a few minutes unpacking each of these. I also have no idea what time I'm supposed to be finishing, so someone should probably tell me that. 20. Okay, fantastic. Let's start with composable then. So this is kind of easy to describe, but then it gets kind of tricky quite quickly. So code that's easy to use gets used and used and used and used, right? That can also, there's a double-edged sword, right? If the code that you've got is something that write pads a string, say, and then the whole internet starts using it, and then you delete it, you can really trip some people up, yeah? But code that's easy to use gets used and used. So what does that mean? I want a small surface area. I want code that is narrow and useful, okay? Because smaller things are more composable than big things. There's less to learn, less to go wrong, less to conflict. My very first open source project, bit of code I wrote, was back in 2004, I think. And it was because WebSphere, which was IBM's Java, enterprise Java container, was an absolute dog. So if you think like, deploying, spinning up a Docker instance or whatever, is like takes milliseconds. Hot deploying things into, I don't know, a node stack or whatever. This would be multi-minutes, right? You'd make a one-line code change, restart WebSphere. Nope. So it had a process called EJBC. What EJBC did was it took your Java source code and a bunch of XML files and used that to code gen a bunch more Java source code, which it would then compile. It would then zip that up into these things called jar files, which is a zip file full of Java classes. And anyway, it was and so I wrote this thing called XJB, which is like EJB, but from the outside. So in other words, it stubbed all of the bits of EJB, of the container lifecycle that you cared about, and you could write tests. And this thing just ran, boom, like that. And I was very pleased with this, and I open sourced it. And a buddy of mine said, "This is great. Why has it got log4j in it?" Because it's very prescient. It was like, in 20 years' time, there's going to be a massive exploit in log4j. No, he didn't. But he said, the thing is, right, because I'm like, everyone's using log4j, dude. It doesn't matter. And he said, well, it kind of does, right? Because you're using a particular version of log4j in this code. So if I'm using a different version, because of the way Java works, you're kind of stuck, right? I can't use your thing. I might not even be using log4j. I might be using a different logging framework or not at all. And you've just created this thing I have to drag in now. And so now suddenly there's more to go wrong. And it turns out that it was pretty trivially easy to remove the thing. I didn't need it. Make it intention revealing. Okay? Give it intention revealing name, intention revealing purpose. I want to be able to discover it. I want to stumble across it. I want serendipitous code. Yeah, I remember with, again, another Java example, using the Spring framework. I was about to write a thing in Java to do JDBC, which is Java database stuff. And I was kind of fed up with writing the try finally thing where you try and get a connection and then you open the connection and prepare a statement and run the statement and get all of that is just kind of boilerplate. So I wanted something that I just gave it a query and it would be like a JDBC statement executor. So I start typing in JDBC statement executor that I'm going to create, and then my IDE pops up and says, "What do you mean this one?" So I don't know, do I? And I click through, and lo and behold, is exactly the code I was about to write. Yes, I do mean that one. Thank you, good naming people, or at least coincident naming people. That just saved me a bunch of work. Easy to discover, easy to evaluate. I want to know quickly whether or not your thing is the thing I need. And again, minimal dependencies. We just had a lovely Erlang talk, the late, wonderful Joe Armstrong. This is him describing object-oriented code. He says, you want a banana, but you get the whole gorilla. Yeah? I just want this tiny little function, but this function is a method on a class and a package and a module and a bunk, right? Why can't I just concatenate 2 strings? Because, and it's the same sort of thing. If I can take my thing, if I can take your thing and just drop it into my stuff and not have to worry about anything else, we're golden. One of the things that Go as a language does really well is it forces the dependency conversation upstream. It makes dependency resolution a developer time constraint rather than a runtime constraint. Right? There's no class path or load path or run path in Go. You've got the version of stuff that got linked to that code when it got built. You can run those bytes. So this is composable code. Composable code, small surface area, intention revealing, minimal dependencies. Unix philosophy then. So Unix, I'm actually the same age as Unix. Unix and I are roughly, I think Unix is about a month and a half, 2 months older than me. So I was born at the epoch, or just before. I'm infinity old. But like you look at Unix, right? Unix as Linux is running everywhere. Unix as Mac OS, Unix as Android, Unix as FreeBSD, right? 50 odd years on, half a century on, it hasn't changed much, right? Because what they did is they got a very simple concept and that was it. Everything's a file, right? Disk I/O is a file. The network's a file. Memory is a file. Eventually they got that right. Memory is a file. Everything's a file. And files contain text or not text. And if they contain text, you can do stuff with them. And if they contain not text, you're on your own. And that was basically it. And so the idea was that you make each program do one thing well. And it only does one thing. So ls is the example I like. So ls will list files or list information about a file, list a directory, million which ways. Turns out, ls doesn't actually know how to ask files. That's not its job. Its job is presenting stuff. There's another system call called stat. And stat is the thing that knows about files, right? But it doesn't know how to present stuff. So you say, right, well, stat, you tell me about this, the contents of this directory or whatever it is. I'm going to make it look pretty. I'm going to tell you whether it's a symbolic link or what its modes are or whatever else. And so when you have doing one thing well and composability, you can basically do anything, right? So cat gives you the contents of a file. That's it. That's all it does. It just goes, here's the contents of the file you asked for. grep is a filter. It finds things in the file. Sed transforms whatever you give it. It has no idea that what you're giving it was filtered from a file. Sort takes its contents and guess what? Alphabetical sort or whatever sort you want. Unique removes any duplicate lines and so on, right? So I can compose these complex pipelines of processing from these lovely little atoms of do one thing. But isn't that the single responsibility principle? I hear you cry. Why no, I answer. There's a difference here, right? I'm talking about what the code does. I'm a consumer of the code. A single responsibility principle talks about how the code is structured, right? How the code changes. At this point, I'm going to troll myself because I feel I should, right? So I've had this beef going with the internet for some time. And I've been saying about solid and about clean code and some of these things, the difference between aging like wine versus aging like milk. Okay? Things that age like wine. Continuous delivery. Right? Dave's at this conference. Dave's one of my absolute favorite human beings, Dave Farley. Right? Co-authored continuous delivery. I was at ThoughtWorks when we were kind of having these ideas for this book. And Jez and Dave wrote that, captured them, articulated them in a way, and it has aged well. Right? It hasn't just aged well, it has changed our industry in a good way. It's got a brilliant towards in it, right? So it's only in the last, I'm going to say, handful of years that I've heard in mainstream, if you like, adoption of the term continuous delivery. This book that was written in 2010 or something. Likewise, the goal. Ellie Goldratt, written in probably late 80s, about theory of constraints, about flow, about understanding how work moves through an organization and how to structure an organization so that it can become highly effective. I use principles from both of these day to day. Meanwhile, I'm going to be very specific here. Aging like milk means this. at one point they were fresh, right? In the early 90s, Scrum wasn't just fresh, Scrum was revolutionary, right? Scrum said, in a context, in an environment where people would literally, you do a release every 18 months to 2 years, was fast, right? And Scrum said, we're going to do a release every quarter, every 12 weeks. And we're not just going to fly blind for 12 weeks, we're going to sprint for 6 weeks, course correct, sprint for another 6 weeks, do a release. Let me put that in context. They're saying, we think that the state of the art is doing one release per season, okay? Which isn't exactly a high bar, but then it was impossible, right? And so, they had to invent their way out of things, right? So over a 2-year project, every month, I might have some kind of steering group. Well, if I've got 6 weeks, I don't get to do that. If I did it every week, I only get 6 of them. I'm going to need to do steering every day. Oh, I just invented the stand-up. No one said do a stand-up. They said make sure you know where you're going, right? In a 2-year program, I do months of analysis, months of design, detailed design, get all my people involved, do some coding, testing stage 1, testing stage 2. I haven't got time to do that. I've got 6 weeks, right? I'm going to have to grab people from all those teams and sit them in the same place. Whoa, co-located teams. Who knew, right? So no one said do co-located teams. They said, show me something in 6 weeks or someone's going to die, right? And we're, how are we going to do that? Quick, Martin, get over here. I can't afford to email you everything. And so these ideas were brilliant 30 years ago. Nowadays, I can spin up 15 ideas in a morning, right? On thousands of servers that aren't even my servers. What kind of insanity is only having a 2-week planning horizon? Right? I shouldn't be planning every 2 weeks. I should be planning every 2 minutes. Right? While I'm doing my 2-week sprints, someone else is eating my lunch. Yeah? This doesn't make sense. It has not aged well. Clean code. I took Uncle Bob on holiday. Much to my wife's dismay, I decided I should really finally actually read. I know about Solid. I hadn't actually read Clean Code, right? Mea culpa. I'm going to read this book. It's spawned a movement. It's blah. I'm thinking like pragmatic programmer, refactoring, extreme programmer. I read this book. It's a shocker. It's a shocker. I'm not rude about many things. I'm not polite about this book. I'm reading it on the Kindle and I'm making notes on the Kindle. My poor little Kindle screen is taking 240, it turns out, comments. Right? I've written in this, and there's a whole thing I want to do about like taking clean code and saying, if you took that code and actually applied CUPID, what would you end up with? But 240 comments, a lot of which start with no. And then some words, right? I'm not going to climb into it right now, but I mean, it's painfully enterprise Java centric, but in a way that's sort of gatekeepery. Like it just uses these terms like ears and jars and wires and assumes that you know that. And it talks about it's so macho. It's like you got to grind knowledge into your eyes and fingers and sweat over it. And I'm like, dude, that's not how we do things. That's not very. And then this whole adversarial thing about developers versus managers and developers having to fight managers to get. I'm like, mate, no, right? I don't know where you're working, but that's not what we do. And one of my notes is this. James Gray. So a lot of the chapters are contributed by other authors. James Grenning contributes a chapter about boundaries, and my notes are this: an oasis of clarity and applicable ideas. I'm like, I read this in the middle of this book. I was like, finally, I agree with everything in this chapter. So, and there is some great advice in there. But it was great. It's aged like milk. By the way, I learned yesterday from Holly that things are funnier if you put a duck in them. So here is clean code, aging like milk, and a duck. Okay, so now, anyway, back to our rescheduled talk. Predictable. Let's move on. So predictable. What do I mean by predictable? I want predictability in code. Well, the most obvious thing about predictability is it behaves as you expect, right? It behaves as expected, no surprises. Right? I don't want surprises when I'm running code. Ken Beck's lovely phrase, he says, passes all the tests. And I'm like, yes, even when there's no tests. Right, so that code base I was telling you about 30 years ago, the image processing C thing, 0 tests, utterly predictable. I could look at it, I could see what it was going to do, I could have guessed what it was going to do, run it, and it kind of did, right? Which is joyful. It's joyful. It means I can get on with work. It means I feel comfortable, yeah, and all those other lovely habitable things. It so behaves as I expect it to behave. It's deterministic. It does it again and again and again. Each time I run it, guess what? It doesn't blow up. It doesn't. And determinism isn't just about what the code does. It's about how the code works. Things like resource utilization, things like memory and CPU and stuff, and it doesn't suddenly spike. Right? Or if it does suddenly spike, it's because I'm expecting it to spike because that's part of its operating characteristics. So it's well understood. One example, about 12 years ago now, I was working on an algorithmic trading system. So algo trading is quite complicated. You've got you've got to connect to an exchange, which is then sending you a fire hose of data. So you've got a huge kind of data volume problem. You've then got to so the way you win at trading is you have a better model than the other folks and you execute faster than the other folks. So you're squeezing milliseconds, microseconds, nanoseconds out of these algorithms. You're putting code into network switches on the network because the closer the code is to where you need it to be, the faster it's going to execute and stuff. So this is a very, very complicated environment. And it has to be a very deterministic environment because you've got traders looking at this thing and they have to be looking at accurate information because they're making trading decisions based on it, right? That code base, that trading stack, I did an audit on the code. We had, what was the test coverage? So this is some of the most, I would say, XP-like programmers I've ever worked with. There's a small team, about 5 of us. What was our code coverage metric? Have a guess. There's no wrong answers. It's not 0, it was more than 0. Come on. 60%? 20%? 100%? 7. 7% test coverage, right? Here's the thing. It wasn't uniformly 7. It was very unevenly distributed. There were parts of the code base that had no tests because they didn't need tests. You're running it all the time, right? And if it's going to do something odd, it's going to do something odd in front of you, right? You don't actually need tests for that code. Spoiler, right? There were some parts of the code we made up new types of testing because it absolutely had to be right. We were doing like property-based testing. We had some system that was just ticking away. It was trying to kill a state machine that we'd built. And every now and then, literally every few days and then every few weeks, there's like a power curve of bugs, it would just pop. God, what's happened? Oh, it's just come up with some crazy sequence of events that leads to a fail. And we're like, oh, interesting. Is that crazy sequence of events ever likely to happen? Because if it is, we should fix that. If it's not, then it's just a useful data point. So it changed my attitude about what to test. So for instance, before I was doing this, when I was sort of ThoughtWorksy, Agile Dan, BDD, telling people how to write code because I know, right? Wow, hubris. Turns out I didn't. Is I would say, right, write tests for start with a happy path and then go the increasingly unlikely blah. And now I'm like full 180, right? You don't actually need to test the happy path. You're in it all the time. If it's going to fail, you're going to know, right? Test the things you don't see. Test the bits of the town you don't go to very often because they are the bits that, A, you don't go there very often. And also, because you don't go there very often, if you introduce a regression, you might not notice it for some time. And and it may be then it's really hard to dig your way back out of from that. So deterministic and observable, and this is observable in the I used to call it the engineering sense. I now call it the mipsy-tipsy sense. So in the charity majors, observability. So internal state can be inferred from outputs. So I can look at what something's doing, and just based on what it's doing, I can be really confident about what its internals look like. And it is, I'm going to say, vanishingly hard, right? Enormously hard to retrofit that. You design that in from the get-go or you don't have it. Okay? Idiomatic. Idiomatic, then I'm going to speed up a bit now, uses language idioms. So this is the ego property, right? This is the put your ego aside. I'm not going to write code like Daniel. I'm going to write code like everyone else. Because if I write code like everyone else and everyone writes code like everyone else, then all the code looks like anyone could have written it. And that's a huge amount of cognitive load. I don't need to crack open the code and, this is Martin's code because it's written in Martin's style with Martin's whatever, and now I need to shift mode into that thinking and da-da-da. No, if we're all writing code in the same way, and we all choose what that way is, that's just another level of thinking I don't have to do, and I can focus on getting work done. So use standard features, use constructs, use standard libraries, use the tooling that everyone uses, right? And if it sucks, change it, right? And make that the tooling that everyone uses. Yeah. Make it so it feels natural. You know, when I first started learning Python, I was writing Java in Python because I was coming from Java, and there were classes and objects all over the place. And it turns out that once you get over that and you chip it all away, all you end up with is a tiny amount of code, which is what you needed in the first place. And the rest of it was you just trying to impose Java on poor Python. So once you learn to go with the grain, you start writing Python in Python. Yeah, and ditto lots of other languages. And it's not just the language idioms, it's what do we do here, right? So let's find out what we do here. Sam Newman has this lovely quote, and he doesn't remember saying it. I was there when he said it. He said, "It's better that things are consistently wrong than inconsistently anything." If they're all wrong in the same way, we can decide we're going to go fix it. Yeah. If they're inconsistent, we've got no starting point. And in fact, the starting point is to make them all consistently wrong. Yeah? And then you can go somewhere else. So understanding house styles, and that they might not exist, right? They might be de facto, they might be tacit. So you've got to make them explicit. And then think about the project dependencies, what's going on in the organization. Turns out you can only write idiomatic code if you bother learning the idioms, right? So that's on us, yeah? When you're learning a new language, it's not about learning the syntax and getting it to compile or run or interpret or whatever it's going to do. It's about understanding how people in that ecosystem write code in that ecosystem. And once you get there, now you understand the language, okay? And it's okay for that to be bumpy, and it's okay for that to feel weird. And some languages have a very opinionated, so Clojure or Python, Lisps and those kind of languages are very opinionated. They're very small languages. They're enormously expressive. Conversely, Scala, right, or Ruby, the language JavaScript, there's so many different programming styles you can do in those languages, which means as a team, as a code base, as a product, you need to have opinions. You need to say, well, in this code base, this is how we're going to do this thing, right? And then finally, domain-based. So there's two parts to this. There's the obvious, what I call the obvious part, domain language, code in the language of the domain. I contributed a chapter to the 97 Things Every Programmer Should Know, Kevin and Henry's lovely series, about coding in the language of the domain, the idea that you use words that traders would use or that healthcare people would use or whatever. And remember, there's multiple domains. But the other part of this is that we want to use domain structure. Okay, so typically what I see, if I crack open a Rails code base, yeah, there's models and views and controllers and all kinds of other stuff that are all Railsy things. Yeah, that doesn't tell me anything about what we're doing here. If instead I crack it open and I find a payments module and a loans module and an onboarding module, I can go, oh, right, I can see what this product probably does. I can see what this code base does. When I want to go in to change something, again, if I want to change something about payments and everything's structured for the framework, I've got to go into the models thing and change that, and then the controllers thing and change that, and I forget to change the thing in the views, and so on. I'm hopping all over this code base trying to get something done, yeah, rather than ending up in a single place. And then domain boundaries, and this is about bounded context. And think about use domain boundaries as module boundaries. So in other words, your deployable units, right, are bounded units. They are subdomains of functionality. And if you're deploying subdomains, then it means that as those subdomains change, or as your understanding of those subdomains change, going back to Dave this morning, talking about iterating on ideas. As we're iterating on ideas, we're deploying just the parts of that we're learning about. And if we get the messaging and the protocols between those boundaries right, so we do our domain modeling well, and we've got our message passing, then it turns out that these pieces can move independently from one another. So there we go. CUPID. Composable, Unix philosophy, predictable, idiomatic, domain-based. Very quickly then, here's where I've heard people using it. So this was February last year. So we're about a year and a half on now. People have been using it as a lens for assessing code. That was one of my favorites. So we've got this big code base. I've inherited this big code base. I want to know where to start. Let's look at it in terms through a lens of composability. To what extent are the various parts of this code base composable? To what extent are they idiomatic? To what extent are they predictable? And that might involve writing a bunch of characterization tests, Mike Feathers calls them. I might need to write a bunch of code to understand how this code works, right? Using a code critique. So code critique, I know Jessica was saying she hates code reviews. I hate code reviews. I don't want to be a cop. What I do want is to learn. And I see a code critique as a companion to pairing. I'm a massive fan of pairing. Code critique is about the team creating those idioms, creating those norms. And saying that as a team, we're going to look at, it turns out we've got this particular way of getting data from that service in 3 different places now, done 3 different ways. So as a team, let's critique each of those and decide which one we're going to use. Because then as a team, we've now got an idiom around that. Yeah. And one of my favorite hacks, if you like, for code critique is I like to get junior people to critique senior people's work, right? Or less experienced, newer people in the team to critique more experienced people's work. It completely shifts the power dynamic, right? It takes all of that out of the room. And also, newer people ask really good questions, right? Like, why is that there? And everyone goes, crap, really good question. I've no idea. Why is that there? Well, now let me tell you why that's there. And so as a team, you're then continually learning. Deciding where to start. So this was again with this legacy application this chap had taken on. He said, we can't boil the ocean. We're not going to do all these things. What we need is we need to go after predictability first. This thing's all over the place. And of course, because all of CUPID are all intertwingled with each other, the more you go after predictability, the more you're likely to end up with domain-based, idiomatic, code that's doing one thing, etc. And I've been talking to someone recently about using it as a syllabus for a programming course and taking code and moving it along these various axes. So a year down the line, I appeared on front page of Hacker News, which was fab because unfortunately it was slightly out. It was on the 15th of, it's not there, it's not showing up. If you look at the date, it's the day after Valentine's Day. That would have just been perfect, right? I know, off by one error. Spiky traffic is spiky. This is my website, right? So I'm rubbish at the social media thing and the blogging thing. So when I blog, it's like nothing, 50,000, nothing, right? So shout out to Fathom Analytics, which is brilliant. And I ended up on the ThoughtWorks radar, which I was more surprised than anybody. Someone said, do you know you're on the ThoughtWorks radar? So yeah, as a what is it, assess or whatever. Yeah, check it out, folks. So what I did is I ripped the article apart that I wrote into a little website called cupid.dev. Much more accessible, much more discoverable, much more linkable. Every paragraph is anchored and all that. And we've got a little news group as well, a mail group. So come and say hi. And I really want to hear your stories. Okay, so that's really all I had to say. Is I'm getting very excited that people are adopting this and they're trying it out. And so I'm really interested in case studies, really interested in your stories. So I think we're out of time, are we? Are we over time?
Yes, thank you. You made it somewhere between 39 minutes and 39 hours. So
that's called estimating.
Yes.